report to the main gym at 11:30. All AT psychology students will report to the main gym at 11:30. Make sure you eat A or B lunch. All AP students need to make sure that they have a school-issued ID card. School-issued ID card. Your cell phones, driver's license, state IDs will not work. Thank you.
All right, let's try that again. So we want to know the probability of picking an 8th grade student. Yes. So we have 180 8th graders out of 545 total humans, which we could simplify that, but I am also 100% with us not simplifying it down. If we want to simplify it, we're going to go ahead and type it in the calculator to simplify it. We'll get 36 over 109 because both of these values are divisible by 5. But I can't do either one of them off the top of my head, so. So now we're going to look at 2 different conditional statements. The last 2 are 2 conditionals. This one says your sibling is in 6th grade. So we know they're in 6th grade. What is the probability they like skiing? Yeah. So the number of people that like skiing is 41 out of our 155 total 6th graders. And then you go and you start doubting yourself. You're like, wait a second, maybe I don't remember correctly and my sibling is in a different grade. I know they like skiing. I remember how much fun they had on a ski trip. I know they like skiing. They are a skier. What's the probability they're in 6th grade? So now I'm not entirely sure they're in 6th grade. I know they like skiing. What is the probability they're a 6th grader? 41 out of 171. So it's a different population. It's still looking at that same group of 41 6th grade skiers, but it's different populations. So the purple one, that is finding the probability they like skiing if I know 6th grade. That's how we would put it in notation. And this one is probability of 6th grade if I know they like to ski. So it's very subtle difference. All it does is switch the 2 things. It's a very subtle difference, but that's what that does. Okay? Questions about any of these? Okie dokie, artichoke. So we're going to do our last set of data, our last set of notes. So we're on page 18. And we're going to talk about outliers today and when we will use median and when we'll use mean, because both of those things find the middle. They just find the middle in different ways. So what we're going to say for an outlier is a value in the data set uncommonly or rarely or really far from all of the others. So it's a value in our data that is uncommonly far. It's a weird one. It's something that's abnormal. So if we think about looking at say, the average height of a group of kindergartners, and you toss one random NBA player in there, they are going to be an outlier. They are really far away from the average height of those kindergartners. So it's a value in our data set that is uncommonly far from the others. And what we're going to do is we are going to find our mean and median of these two data sets and see what happens. Because for the most part, they're the same. This right one just has one additional piece. It has this 50 tacked on the end. So we're going to start with finding our mean here, which is when we add up all those values. 3 plus 8 plus 2 plus 9 plus 7 plus 6 plus 8. And we're going to get 43 over 1, 2, 3, 4, 5, 6, 7. And 43 divided by 7 is about 6.1. So the average is about 6.1. Then we're going to find our median. That means I do need to put these in order. So putting these in order, we have 2, 3, 6, 7, 8, 8, and 9. So what's our median? 7. So our mean and our median aren't far off from each other. They're fairly close. They're within one number of each other. 6.1 and 7 are not awful. So then let's see what happens if we get this one random outlier of 50. Everything else is the same in the data set. So we still have our 3, 8, 2, 9, 7, 6, 8, and 50. So when we get our mean, with just adding that one additional piece of information, we actually get 93 over 8, which gives us a mean now of 11.6. But what's our median? We got to find that, so we're going to put it in order. Again, it's that same data set, so for the most part, it's the same. We've got our 2, 3, 6, 7, 8, 8, 9, and then it's got this 50 on the end. So where's our median going to be? Yeah, it's right between the 7 and the 8. So when it's between two values, we find the average. So the average of 7 and 8 is about 7.5. So we do expect the values to change when we add another term. However, what happened when we added an outlier to that mean? Is it in the middle of my pieces of data over here? No, it's like they're saying my average is over here. If this is order, this is number line, 2, 3, 6, 7, 8, 9, 9. It's putting the middle somewhere over here. Whereas on this one, the average puts the middle around here, which is right next to my mean, or right next to my median. So what we're looking at down below there, below it says, in your own words, describe what an outlier does to the mean and the median. You're putting it in your own words. We should hopefully notice that on my without the outlier group, my mean and my median are fairly close, and they're both vaguely in the middle of the data set. When we do have an outlier like that, my mean gets pulled really, really far towards that outlier. So you're putting it in your own words to describe what we notice here.
you.
Bless you.
Thank you.
So the very last piece on this first page is asking about, and I didn't actually put it up here, when we use mean and when we use median. So it says, because of this, how do we find the best measure of center with and without an outlier? Well, when we don't have an outlier, when there is no outlier, we tend to use mean. Because it's the most accurate measure of center, it's giving us our average. We like averages. There's oftentimes when we're looking at tests, we're looking at class average, we like averages. However, if there is an outlier, that mean gets shifted really, really easily. It gets very easily distracted. So when there is an outlier, we use median. And we can tell when we have an outlier by seeing, first of all, if these are fairly close together, there's no outlier. If we're looking at a picture, no outlier stuff will be symmetrical, like matchy-matchy-ish. Meaning, so like box and whisker plots will have vaguely the same size pieces like that. And when there's an outlier, it's what we call asymmetrical. Which means we're going to have one really small side and one really big one. So when it's asymmetrical data or not matchy-matchy, it's going to be that we use out there. That's when it has an outlier. So the last piece we're really thinking about is we're thinking about how we can talk about how spread apart things are. We did a bit of this yesterday looking at these box and whisker plots when we talked about our IQR, or the width of the box, which works really, really well when we're using our box and whisker plots, when it's asymmetrical or when it's symmetrical like this. When we're going to use our when we use our median as our center, we're going to use the width of the box to figure out how far most things are from the middle. So when we're using median, we're going to use our interquartile range because that's based off of our median. Those were all based off the median and then the median of the leftover pieces. That's what we did yesterday. So when we're using mean, I don't want to base my center off of my median because they're not quite the same. We're calling this the center. I'm not going to base everything else off my median. So when we use mean, we're going to use a new thing, which we are 100% not going to calculate because honestly the equations for it's gross. We're just going to talk about what it means. And that's something called standard deviation. And standard deviation is a measurement. How do we spell measurement? Of width of the majority of values from the mean. So our inner quartile, oh, sorry, I didn't realize it was still following me. Our inner quartile range says how far about half of them are from the median. Standard deviation tells you how far most, literally a majority, it's 2/3. A majority of values are from the mean. It's how far they are from the center. So it's a measurement. So the bigger the value, the farther apart they are. The smaller the value, the closer together they are. So we're looking for where we have most things fairly close to the median. Or mean, I'm sorry, I keep saying them backwards. So since we're looking at the measurement of these three pictures, which one has the farthest apart pieces? Which one has the widest measurement, the greatest standard deviation? The third one. What standard deviation tells us is if I know my mean is somewhere around here, and because this is symmetrical data, that's going to be where it is. Most values are around here. That's what our standard deviation is telling us, is most values are there. I've got most of them. I don't want all of them. I just need most of them. So this one has the biggest standard deviation. Which one has the smallest? The second one. Our average or our mean is going to be around here. And I can get most of my points right around here. So this one has the smallest standard deviation. So all it is about looking how many are, how close they get to the mean. So then if we think about what the outlier does to the mean and why I can't use this for everything. If I didn't have this little dot on the side, I'm just doing an example, our mean would be somewhere in here, and I could do a standard deviation. It'd be totally fine. When we do have this, we saw what happened with the event that we did at the very beginning. It pulls my mean really far over to the side. So the distance I have to go to get most values into my standard deviation is a lot bigger. So if I didn't have this outlier, my mean would be somewhere around here, and my standard deviation would look like this. I would get most of them this way. But since we do have that outlier, my mean gets pulled over this way. And so my standard deviation gets a lot bigger. So since outliers, the way I'd word that, since outliers move the mean, they make the standard deviation, which you can abbreviate as SD, a lot bigger. So what that means, because of this, when we're talking about measures of spread, meaning standard deviation or interquartile range, it's really based off of the same way we choose how we measure the center. So if we use mean, meaning there is no outlier, we measure what's called spread, which is just how far apart the points are. with our standard deviation. So if we use mean, we use standard deviation. If we use median, meaning there is an outlier, that's when we are going to use our inner quartile range. We measure spread with our IQR. And we are not going to go super into depth onto each one of these things. Like, if you are interested in that, please go take stats. It's honestly really interesting. I feel like we're really barely touching on it here. So if we use mean, we use standard deviation. Those guys go together. They are buddies. Standard deviation is the width based off the mean. If we use median, we use our inner quartile range. It is the width of the box based off that median. So mean with standard deviation, median with IQR. That's how they go. So the last thing we're going to do, like this is our last bit, is on page 20. We're going to look at these three pictures. And we're going to decide which one we're going to use. So looking at this first picture, what is going to be our best option for measuring the center? Are we going to use mean or are we going to use median? Median. Why? Because this little guy over here, we have an outlier. We have one point that's way far away from the others. So because there is an outlier, I'm going to just put that in my Y. There is an outlier. Since there is an outlier, we are going to use the median to measure our center. Since we're using median to measure our center, we are going to use our inner quartile range to measure the spread. Median and IQR go together. They are buddies. How about on this one? What would be our best measure of center on this graph? Mean. Why? There's not an outlier. We don't have one. So there is no outlier. There's an L in outlier. So if we use mean, we measure our spread. We measure how far apart they are using standard deviation. What do we think on the bottom one? Mean or median? I'm good with mean. This one's really hard to tell. It's really hard. There is a calculation we can do to figure it out, but we're not going to do that, like you. So this one is really hard. It's hard to tell what classifies as an outlier lot. So if we're not sure, go with mean. If we use mean, that means we use standard deviation, and it's really hard to tell if there is an outlier. So if there's an outlier, we use median and IQR. If there is not an outlier, we use mean and standard deviation. If it is really hard to tell, we're going to use mean and standard deviation. There will be times when it is not hard to tell, even with a box and whisker plot. If I have one, I'm going to do it on the next page. If I have one that my box and whisker look like this, that very clearly has an outlier. Because if my box was here, it would be fairly symmetrical, but it's not. So something really long like this, that definitely has an outlier. But something that kind of close together, I mean, everything's between 1 and 8. It's not super duper far. So it's really hard to tell. So that's everything. That is everything for the chapter. When you came in, a lot of you guys noticed I put it in the Algebra 2 tray, the paper review for the chapter test. If you didn't pick that up, you can pick that up today or on your way out, or you can pick it up tomorrow. I don't really care. There is also a review on Canvas. There is also a review on Alex. There are lots of places where you can review, where you can practice this stuff. The homework 5 also talks about the center and spread, so you'll need to remember this stuff when you do homework 5. So tomorrow and Monday, we will have time to work on the review. Tuesday's our chapter test, and then we're getting ready for finals. That's kind of the plan for the rest of the year. We're almost there. Yes, dear. No, this is just notes. Please don't turn in your notes packet. I don't want to have to keep track of them.